We want to work on solve this worksheet, and this is implicit differentiation where we assume my function y actually explicitly depending on x. So whenever you do this, like I said, you imagine the problem was depending on x directly, and the derivative is 2x, and you change things back because it's essentially about y, and don't forget chain rule tells you you need to modify it into y prime, multiply the derivative inside layer. So what you end up with is 2y times y prime. Okay, but it only works if your problem simply depends on y without x. Otherwise, you can't tell the difference between x and y. So if you have a mixture of two parts, you apply the rule that's needed first. For example, x times y squared, it's a multiplication, so you use product rule first. So end up x prime times y squared plus x times y squared takes derivative with respect to x. So end up with 1 times y squared plus x times you had y squared again. You need to use chain rule, which we just said earlier, it's 2y, but you need to multiply y prime back, so this is your answer. So for this problem, this is clearly a composition of functions, so you want to use chain rule. Chain rule takes differentiate of the outside layer, which gives you cosine, time with the inside layer substituted in, and then you multiply by the derivative of the inside layer. So what you end up with is cosine of xy times x prime y plus x times y prime, and now you simplify your structure, so you end up with 1 times y plus x times y prime. Okay, so the next problem, along the same line of thinking, you want to take derivative. That's two parts add together. So you have y plus y squared takes derivative plus y to the power of 1/2 takes the derivative. You first imagine this function as something that's depending on x, so you take the derivative of that. Well, technically this is a chain rule, so you take the derivative. It's like y plus y squared. Sorry. Yes, on the exponent, and then you differentiate what's inside, which is your inside layer, and then you had your other part takes derivative, so it's 1/2 y to the power of 1/2 minus 1. You take the derivative of the inside layer, so you have ey plus y squared times y prime plus 2y y prime plus 1/2 y negative 1/2 y prime. So this is what you end up with. So always remember that you need to apply the chain rule, and you want to follow the structure explicitly. So for this problem, you need to take the derivative on both sides, right? So you take derivative about x, it's 1. You take derivative about x, it is e to the y times y prime. Therefore, you have 1 over e to the y equals y prime. So you find what's the dy over dx, or on the same side you could say what's y prime. So similar here, if you want to take the derivative, you take derivative on both sides, it's negative sine y squared, and then you take the derivative of y squared, you take the derivative of x, and then you have e to the y to the 1/2 takes the derivative, so you have negative sine y squared, and then you have 2y, and then you have y prime here, you have 1, you have e to the y to the 1/2 times y to the 1/2 prime. Again, every time you only use the rule that's appropriate, and you only use one rule at a time. So what you end up with is negative sine y squared times 2y times y prime plus 1, which is e to the y 1/2. You have 1/2 y to the negative 1/2, and don't forget you were taking the derivative of x, so you have to use chain rule here. So this is y prime. Now you know that you have y prime in two terms. You want to put them together on the same side. So what you end up with is negative sine y squared times 2y times y prime minus e to the y to the 1/2 y to the negative 1/2 times y prime equals negative 1. So you factor the term, sorry, my bad, I forget to write. I wrote y prime and y squared. So you factor out this term, so you end up with negative sine y squared times 2y minus e to the y to the 1/2 y to the negative 1/2 times y prime is negative 1. So you get that y prime is negative 1 over negative sine y 2y minus e to the y to the 1/2 times 1/2 y to the negative 1/2. Okay. So similarly, the next problem, we want to take derivative. You use whichever rule that applies to it first, okay? So what you have is e to the x squared times y squared. It's chain rule, so the derivative of e to the power of something is itself times the derivative of the exponent, which xy takes derivative, so you end up with ex squared times y squared. This is a product, so you use product rule, so it's x squared prime times y squared plus x squared times y squared prime plus x prime times y plus x times y prime e to the x squared y squared 2x y squared x squared. You have y squared takes derivative, so you have chain rule. This is only depending on y, so you end up with 2y, and then you get y prime because of chain rule, so you have 1 times y plus x times y prime. You do want to single out y prime, so you have e to the x squared y squared times 2x y squared plus e to the x squared y squared x squared times 2y times y prime equals y plus xy prime. So I want to move those two terms on the same side and everything else on the other side. So I have e to the x squared y squared 2x squared y prime minus xy prime. It's e to the negative x squared y squared 2xy squared plus y. So now you factor out your y prime term. So what you end up with is y prime times e to the x squared y squared 2x squared y minus x, which is negative e to the x squared y squared 2xy squared plus y. So you end up with y prime being negative e to the x squared y squared minus 2xy squared plus y. Sorry, multiply here, my bad. Divided by e to the x squared y squared times 2x squared y minus x. Okay, so this is what we end up with a final answer. So find the equation of the tangent line of the function. So essentially what you want to find is what's the y prime at the point of 2, 1, and then you just put everything back in the right position. So first of all, you want to find the derivative. So you take derivative, you end up with x squared takes derivative, plus xy takes derivative, plus y squared takes derivative, plus 7 takes derivative. So it's 2x, it's x prime y plus xy prime, plus 2y times y prime equals 0. So there are two terms about y prime, so you would end up with 2x plus y equals negative xy prime minus 2y prime, which is negative x minus 2y times y prime. So end up with y prime being 2x plus y divided by negative x minus 2y. When x is 2, y is 1, you end up with y prime being 2 times 2 plus 1, negative 2 minus 2 times 2, which you end up with 5. You have negative 6, so this is your derivative. Then you end up with y minus 1 equals negative 5 over 6. X minus 2 is your equation of the tangent line. Okay, so next problem, what you want to do, again, you want to find normal line, which means you want to find the tangent line first and find the one that's perpendicular to it. So you want to find the derivative. In order to find the derivative, again, same idea. You take derivative on both sides, following whichever rule that's appropriate to it. It's summation on the left, it's multiplication on the right. So you end up with power rule. This is to use chain rule. And then you have 2x prime y plus 2x y prime. So you end up with 3x squared plus 2y squared times y prime, which is 2y plus 2x times y prime. You want to move y prime terms together. So you end up with negative 3y squared y prime plus 2xy prime, which is negative 3y squared plus 2x times y prime. Hence y prime is 3x squared minus 2y over negative 3y squared plus 2x. Now you end up with a y prime at the point of 1, 1 being 3 times 1 squared minus 2 times 1 over negative 3 times 1 squared plus 2 times 1, 3 minus 2, negative 3 plus 2, which is 1 over negative 1, which is negative 1. So this is the equation of the tangent line. The normal line is perpendicular to it, so it's taking the negative reciprocal, so you end up with 1. So you have the slope of the normal line is 1, so you end up with y minus 1 equals 1 times x minus 1, which is your final answer. So this is our last problem.